Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all of you. So this is a pre-recorded video for our, I think this week 3. Okay. So series parallel circuit. So we will introduce you the series parallel circuits, and then we have also a special connection of the resistor, where we have a Y connection and delta connection. Where actually this type of connection can be transformed into Y to delta or vice versa, okay, to delta to Y transformation. Okay, let's look at the series parallel circuit. So what is mean by series parallel circuit is actually a circuit that has a combination of all series and also parallel, which is equivalent to what the exercise that I have already given to you, that you need to submit exercise 1A. So that's why you seems is quite difficult, because I just want to see your capability on understanding the series and parallel. Okay, so but this one is actually is, as I said before, is actually equals to the exercise that we have done. So you need to, for this, okay, because inside the circuits, there are a lot of circuit that involve series and parallel connection. So to analyze the circuit, you need to know which resistor are in series and which resistor are in parallel. For example, this first circuit here, okay, for example, you need to find what is the R equivalent that sees from this terminal. Okay, so what to do, so you know that 1 and 5 are in series, okay, and then 6 and 3 are parallel. Okay, so parallel, so this one 6 parallel with 3, you will have 2 ohms. Okay, and this 2 ohms is actually in series with another 2 ohms. So right now this one becomes 6 ohm. So this one become total 4 ohms. So right now 6 and 4 are parallel. Okay, so right now your circuit has become a simplified version of this circuit, where this one is actually 6 parallel with 4. This one is 4 ohm and this one is 8 ohm. So 6 multiplied with 4 over 6 plus 4, so you should get 24 over 10. So this one is 2.4 ohm. So R equivalent that sees from this circuit is 4 plus 2.4. So this one is actually right now R in series. Okay, so the R equivalent is actually 4 plus 2.4 plus 8 ohm. Okay, same what like this. So this one are in series. Okay, and then they will parallel with this one. Okay, so finally you will obtain the circuit. So it's quite difficult to just see this one. You need to redraw. Sometimes you need to redraw the circuits, okay, so that you have the idea what the simplification of the circuit have become. So this one is this one is actually referring to this R equivalent. Okay, so right now you can see this one is right now in series, and then you need to simplify the circuit and so on. Okay. Okay, but there are also a circuit combinations that are not series, and they are also not categorized as a parallel. So this one we have a circuit this like this, what we call Y and delta connection. So what is Y connection is shown in this diagram. Okay, so sometimes it is drawn like this, okay, and sometimes it's also draw like T shape. So that's why sometimes it is Y, or we call WYE, or T shape, or sometimes also star. Okay, and we have another connection that what we call delta connection. So delta connection, or sometimes we call pi. So as you can see, the shape, okay, delta or pi, but it is actually the same circuit. Okay, so this Y and delta connection, they are interchangeable to each other. So meaning that if you have a Y connection, you can transform into a delta equivalent circuit. Same thing, okay, if you have a delta connection, you can transform this delta into Y connection. So what is the equations that involve? So this is the equations involved. For example, given a delta, so this is your delta. This is your delta connection, okay, which is represent as a RA, RB, and also RC. Okay, so how to change this delta RA, RB, RC to its equivalent R1, R2, and R3? So this is the formula. So to get your R1, what you need to do is to multiply the adjacent resistance, which is RB and RC, and then divided by the total resistance, RA plus RB, RC. And then same case goes to R2. So to get your R2 here, so the adjacent is RC and RA. So you multiply them and then over the total of the resistor. And then R3 here is the multiplication of its adjacent, RA multiplied with RB over the total resistance. Okay. And if you have been given a Y connection, which is R1, R2, and R3, how can you transform this Y connection into delta connection, into RA, RB, and RC? So to obtain RA, for example, what we need to do is to multiply the adjacent of the resistor R1, R2 plus R2, R3 plus R3, R1. Okay, and then divided by the resistor that opposite of RA, which is right now is R1. Okay, so to get the RB, you go the same equations. R1, R2 plus R2, R3 plus R3, R1 over the opposite of your RB, which is R2, and so on. So don't worry, these equations usually will be given during your test and also final exam. So do not memorize. What you need to do is actually to know how to obtain this, what we call values. Okay, for example, R1. R2 and R3 and so on. Okay, so this equation is been given, so no worry. Okay, so right now transform the Y network to delta network. So this is our Y. So because my eyes is much more pleasant to see star connection. So I just write down. So 10, 20, and 40. So it's actually up to you. How do you want to arrange this one? Okay. So to get from Y, so this is Y connection into a delta connection. So what you need to do is actually by using this formula. Okay. So meaning that you need to have, for example, to get your RA, okay, 10 multiplied with 20 plus 20 multiplied with 40 plus 40 multiplied with 10 over, for example, this one, here is your RA, okay? And this is your RB, for example, and this is your RC. Okay, so RA, so this one over the opposite, which is 10 ohm. The same case goes to RB. So RB same, so 20, okay, plus the multiply of 20 multiplied with 40 plus 40 multiplied with 10 over the opposite, which is the opposite of RB is 20 ohm. Okay, so that is actually the equation. For example, RC is actually same, 10 multiplied with 20 plus 20 multiplied with 40 plus 40 multiplied with 10 over, so right now RC here, so the opposite is 40. Okay, so it's quite straightforward. But the problem is sometimes the student got confused. So you need to actually do some exercise on the star information. Okay. Okay. Next is this example. For the bridge network, find RAB. So what is the equivalent resistor that sees from this terminal? Okay, what is the R equivalent? Okay, so to find that, as you can see, so R equivalent is actually like this. So what is your RAB? Sees from this terminal. So this one 13, 24, 30, 20, 10, and 50. Okay, but as you can see here, this 24 and 10 are not parallel because you have 20 ohm in between these two nodes. Also, as you notice, 30 ohm and 50, okay, is not parallel, okay, because it has 20 ohm in between. So this one, as you can see, is a delta connection, both at the upper side or in the lower side. So as you can see, this cannot be solved, okay, unless you transform either one, the upper side or the lower side, into a Y connection. Okay, let's look if I change. You can either change the upper side. For example, I change the lower side. Okay, so this one is 13 ohm. Okay, I change the lower side lah. It's up to you. So this one 24, this one 10, this one 20 ohm. Okay. Sometimes it's quite okay, and then this one become like this. Okay. So after I have transform, okay, this one I should have like this, right? So as you can see, I have transformed the delta of the bottom side into a Y connection. So as you can see, for example, this one RA, RB, and this one is RC. As you can see, I can, is it possible? Is it possible now to transform this one? Oh, still not possible. I need to actually transform both, okay, up and the top and the bottom. So I have this one. So this one, I just need to also, okay. So this one will become like this, and then connection with the bottom side. So as you can see, right now we have 13. So this one RA1, this one maybe RA2, this one is RB1, this one is RB2, this one is RC1, this one is RC2. So as you can see, RA1 and RA2 are in series. This one also are in series. Then you can simplify this as a RC1, okay? And then you have a bigger this one. So this one is actually the equivalence of this parallel, and then plus with RC2. So this is actually the RAB. Okay, so RAB is actually the 13 plus RC1 plus the equivalent resistance of these two parallels and plus this one. So as you can see, there are some benefits from the transformation. Okay. Okay, example IO. So I just have a very quick calculation here. So if IO is given 3 ampere, calculate IX and the total power absorbed by the entire circuit. So it's been given IO 3 amperes. Okay, so calculate IX. So it looks like very complicated, but it's actually a very easy questions. Okay, you need to know the concept of parallel and so on. Okay, so for parallel branch, okay, you need to know that the voltage across this resistor are actually similar. So this one voltage is actually similar. Okay, so to get the current here, because you know Ix is equivalent to this one, maybe I1, I2, and I3, right? So it's actually the summation of I1, I2 plus I3 and plus IO. So the problem is how to get these I values. Okay, I3, I0 has been given, which is 3 amperes. So right now, 3 is being given, 3 amperes, and the resistance 16 ohm. You can calculate your voltage drop. So your voltage drop is I multiplied with your resistor. So 3 multiplied with 16 will give you 48 volts. Meaning that all this one is actually 48 volt. So from here, you can calculate your I3. So your I3 is 48 over 2 ohm. Your I2 is 48 volt over 4 ohm. And your I1 is 48 over 8 ohm. Okay. Okay, and then find, okay, so I hope that one clear. Okay. And then the total power. Okay, so the total power absorbed by the circuit. So you just, what you need to do is to just to multiply all the power of the circuit. Sorry, just sum up all the power absorbed by the entire circuit. Okay, so you have already have the voltage, the current, so you can finally obtain your P1, P2, P3, and also PO. Okay, but the only element that you need to also write is actually to get what is this. This one, I think this one is P4. Okay, what is P4? So P4 is actually I x square multiply with E resistor. Okay, so what is Ix? So you need to multiply, need to have a summation of all current, then multiply with R. Then you can get your power absorbed by this resistor. So since this is all resistor, so actually the power is actually positive. Okay, P1. So the total power is actually P1 plus P2 plus P3 plus P4 plus P0. Okay, that is your total power. Okay, and then for the next example, find IO. So as you can see, to get this I, what you need to do is to simplify the circuit so that you have a circuit like this. Okay, so R equivalent. So what you need to do is to find the R equivalent that is from the source. Okay, so as you can see, so this one is series, and then you need to parallel with 20 ohm and so on. So you need to simplify the circuit so that you can get this one. Then after that, you can get what is your I here. Okay, so after you get your I, what you need to do is, for example, the second one is the V out. So this is, I think, more challenging. Okay, so I will discuss this maybe after, maybe during our next class. Okay. Okay, so this one, obtain the equivalent resistance at terminal A, B. Okay, so as you can see, we have this one is not in parallel or cannot be in series, right? So this is what we call pi, and also as you can see, we have also the Y connection. So you can either choose to transform this delta into Y connection and vice versa. Okay, same case with this resistor and network here. You can either change the delta to Y. So this is actually the delta connection. Okay, so you need to change that you can simplify the circuit. Okay, I think that's all from me. So we will discuss. You can try these examples, okay, and then I will give you the answer for this. So this is actually come from your textbook. I think it depends on the numbers of. It depends on the question number. So for the question number that are odd, the answer is actually at the behind of the textbook. Okay, but no worries. The solution will be discussed on our next class. So thank you very much for your attention.